So I was looking to set up a custom private proxy, but I wanted it to be fast and performant. And a buddy of mine was telling me I needed to look at Wireguard. So I'm used to standing up accept tunnels, doing something like Strong Swan from scratch. He was saying, Wireguard's pretty simple, take a look at it. And I'm on my research, I came across some videos from Lawrence Systems, Techno Tim, and fascinatingly enough, I stumbled on these comments under Lawrence Systems video, and I'm not the only one who wants to know how to do this. We're kicking off an initial iPerf test, and look at this, 600 megabits coming in from my cloud proxy. Alright, so let's talk about what this video is and what this video isn't. So this video is not a step-by-step tutorial to set up a WireGuard high-speed proxy. However, what I am going to do is walk through how you would build a high-speed proxy, what your VPS hosting solutions are, what the trade-offs between those hosting solutions look like. I'm also going to talk about all of the notes that I used, so the videos, the links that I used to actually set this up. I'm going to show you a couple screenshots on performance. If there's interest in actually seeing a step-by-step tutorial, let me know. But I looked at what was out there and it seemed like a step-by-step tutorial for WireGuard. There's a number of them, but what was missing was how you set up a high-performance custom proxy. But in particular, when you go to select a virtual private server, I haven't seen nobody talk about what the trade-offs are and why you might go with one VPS provider to solve the solution or another. And that's where all the hard work is at this point, is what is the right VPS solution, what is your use case, and how do you know who to pick? So let's talk through some strengths in doing this. Number one is you can get a static IP for your house for fairly cheap. Number two, you can create a place where you can do some traffic filtering, some traffic firewalling, but from outside of your network. Number three, when you're hosting services, if you decide that you don't want to host that service anymore, you can cut this section out, you can get rid of it. So how's this different from buying one of the VPN services, like a NordVPN or something like that? So the big thing is you own it. You know exactly how it's configured because you set it up. A trade-off for that is with those services, you tend to get like a VPN exit point, egress point, anywhere in the world, or at least, pick your hemisphere, pick your country. In this case, you only have as many as you set up. Cost. The actual all-in cost of a VPN global provider is actually pretty low. So a lot of them, you can do it for like $10 a month. Some of them are as low as like $5 a month. So from that perspective, it's really hard to beat. Although for $5 a month, we can make something smoking fast. Like we can blow away the performance, but you won't get the egress points. Well, another thing is high availability. So if you're setting this up yourself, then if for whatever reason that node goes out of service, then your proxy is out of service. So setting up availability is something you have to own on your own. So let's talk about the different options for hosting your VPN server. So first is your traditional VPS at the big providers. So I'm talking AWS, Google Compute, Microsoft Azure. They're very similar for a couple of reasons. Number one, they support having 2 IP addresses. One scenario that you might want to think about is having a VPN IP address and a external egress IP address. So an IP address you use exclusively for establishing the VPN, and then the IP address that once you get on the host is where all the traffic comes out of. And by doing that, you don't have any cross traffic between these 2 IP addresses. So you just have this encrypted tunnel, all of your information is flowing under it, and then all of a sudden you pop out the other end of a different IP. If you want to do something like that, you need a service that's going to support having 2 IPs. So the big providers have easy access to be able to get on-demand static IP addresses and be able to get multiple of them. They also have good presences at point of presence locations. So you think of the internet superhighway where a lot of data and traffic flows through it, they're there. This is extremely important for people with the lowest latency requirements, which ties into the next one, which is many geographic locations. So internet superhighway a low physical location that's close to you. Those two things combined should be able to get you very good performance, minimum ping, high throughput, things of that nature. But this leads us into the downsides. Typically, their pricing model looks something like the first gigabyte free, and every gigabyte after that is pay, a few cents per gigabyte. I was doing iPerf testing, and I hit 17 gigs transferred in just a couple of minutes. So like 3 minutes of iPerf testing, 17 gigs, and only 1 gig in that scenario would be free. So that leads into the tier 2 providers. When I say tier 2, I'm thinking like Linode, DigitalOcean as examples. They have some really interesting scenarios. One, they have VMs that start at around $5. The other is, in particular, I think Linode stands out in this tier of services. They have really nice network bandwidth caps. So when you rent a server, you get a pool of bandwidth. And I think it starts in the terabytes. For every virtual server you rent from them, each server comes with a certain amount of bandwidth quota. And so once you have, let's say you rent 3 VMs and you have a total of 5 terabytes per VM, then you get 15 terabyte quota for your entire account. Compared to the big providers and even their peers, network throughput wise, that's a much higher number. Also nowadays, even the mid-tier providers have locations in data centers with very good internet access. So even though they may have some less locations, they have enough locations, and those locations are also near the big point of presences. So when you talk about geographic location and high-speed networking, you're in a really good position with both choices and with access to high-quality networking. Also, again, Linode, which stands out significantly with the amount of traffic you can send. All of a sudden, when you're talking about terabytes of data, like you should have no problem gaming or whatever your other use case is. In my use case, I'm looking to average 100 to 200 terabytes a month. Stick around in the channel, you'll figure out what I'm doing and why I need 100 to 200 terabytes network traffic. In short, the traditional virtual private server just doesn't work. You need something that has co-location style networking agreement. So what is a co-location style network agreement? What a co-location is just a fancy word for saying a data center that allows you to bring your equipment, install it in their data center, and give you both data center power, data center cooling, and data center networking. So they work on making all three of those redundant, data center quality, but you rent that space. And they usually start at the smallest being like a quarter rack, then you can go to half rack, full rack, multi-racks of space that you can rent. And you bring your equipment in, you install it, you set it all up, you make sure it's all working, and then it runs out of this data center. Some co-locations also let you rent their servers. So I'm familiar mostly with a service called eSecure Data, but most thing that you have to understand is when you go into a co-location and you get networking, that networking is not bandwidth limited. It's not metered. It's throughput limited, but it's not bandwidth limited. And so what does that mean? That means you might be offered 100 megabit per second base with the allowment to burst up to a gigabit. So you can use 100 megabits all day, all night. It's guaranteed to you at no extra cost. And sometimes you're allowed to burst. And then only if you start using consistently above that, then you go back and talk to them about a different networking agreement. So in this case, eSecure Data has servers you can rent that come with guaranteed 400 megabit with up to 1 gigabit burstable. And they have systems where you can get a 30-something% discount if you rent them for a quarter, guaranteed. So all of a sudden, you could start to get to close to $50, $60 a month. And for these VPN tunnels, their smallest server is going to be way more performant than what's needed. So what you're really paying for is just that unmetered network access. So here's an example setup. It's really just showing you have a home network. You've got your firewall sitting there. You tunnel that firewall to what I call the tunnel IP, and then you have your egress IP. So for visually speaking, it's pretty straightforward, but this is what it looks like. And you can set this up in such a way that only certain devices use the tunnel, other devices don't. You can set this up in such a way where you have a different subnet and only that subnet for the tunnel uses it. What's really nice about this setup though is you only set up Wireguard in your cloud virtual machine and on your firewall. And if you do it in that way, every device gets access to the tunnel without configuration. You just essentially declare which subnets or which IPs are going to use the tunnel. Your firewall will handle routing the traffic in or out of the tunnel. I'm linking towards OpenSense's guide. OpenSense has a really good guide walking through setting this up for them. Looking at this guide should help you if you were doing this in pfSense as well, although the menus won't be exactly the same. And also just even if you were setting this up point to point, I have another document linked as well that describes just simply setting up the WireGuard endpoints. And you also have the two videos I referenced by TechnoTim and Lawrence Systems. That should cover you for the most part. If anybody wants to see me do an end-to-end setup of this, I'm willing to do it. Let me know in the comments. But I'm pointing you towards the really good pieces of information that helped me set it up relatively quickly and highlighting the trade-offs and decisions you need to make when selecting that cloud side of your tunnel. So if you select good hardware and it's good physically located to you, you'll have a blazing fast VPN. And if you go with something that I think is the most bang for your buck, which is Linode, you got a lot of some things you can send through this box and never hit your quota that's in the terabytes. So take a look at Linode if this is what you're thinking about doing. I think you'll get the best bang for your buck there. If you're just using very light traffic, the Amazon Gabitron is a really nice choice. If you're pumping a ton of content, then something like eSecure Data. So my initial testing, I was able to get 600 megabits from one of the cloud VPSs that I set up. After that initial testing I did for the first couple of days, I was not able to repeat the 600 megabits. So I redid this test over, and I have 4 environments here. So in these 4 scenarios related to iPerf, I have the first one was sending traffic from one of the VPS servers directly into the home network. And this one was one that was located very close to me, so it was near a high performance point of presence. And as you can see, I was able to get over 200 megabits per second. From there, I routed that through my configured proxy. So in this case, this would have been a better test if I put the WireGuard endpoint directly on the same VPS host with a good point of presence and then tested it. So in this case, we have other additional network latencies, etc. So as you can see, I got about half the traffic. So I got around 98 megabits per second. Then I started with that other node and I sent traffic not using the tunnel, and it did about 186 megabits per second. In this case, it's much further away, not connected to as high a performant point of presence. And then lastly, I sent traffic from that exact same node through the encrypted tunnel, and I was getting about 157 megabits per second. So in that scenario, WireGuard was able to handle a significant portion of the traffic. The first scenario is not apples to apples, so going from 260 megabits to 98 megabits isn't comparable because the VPN endpoint is on the same host. But at the very least, we can see that WireGuard's performance is pretty reasonable, especially when you think about a vast majority of the use cases, whether or not it's gaming, whether or not it's proxying your own web browsing traffic. So a lot of use cases that you might have, or just running web services out of your home with a limited endpoint out on the web. 100 megabits is pretty reasonable. If you like what you saw here today, I got more home lab videos, more things I'm setting up, more cryptocurrency topics, software development, all that. If you want to see me set this up, let me know. I'm willing to do it. Until then, Curious Tech out.